Alright, we're live. Yay. Alright, we're talking about beta oxidation, fatty acid breakdown. So, first thing that happens, like when you're not hungry, when you're not starving, during starvation, is you eat food, you get high blood sugar, high insulin, and then when you have high insulin, you have high glycolysis and you make pyruvate. And then you make acetyl-CoA. But when you have low blood sugar, you're gonna do fatty acid breakdown instead of this. And then when you have low fatty acid, you're gonna do amino acid breakdown, also called ketolysis. So this is where beta oxidation comes in. The fatty acid breaks down. Well, it's stored as triacylglycerol, and it gets broken down to glycerol. So this tag gets broken down to glycerol. This guy. Glycerol and fatty acids. It's like fatty acids. So the process of going from this fatty acid, well, this glycerol, by the way, this glycerol goes into where, Ethan?
I always pay attention, low-key. Repeat the question.
Where does glycerol go into, this guy? Glycerol. Glycerol. Where does it go into?
It just goes into to be converted into acetyl-CoA, right?
No, it goes into glycolysis. This guy goes into glycolysis. And this guy, this fatty acid goes where?
That becomes the acetyl-CoA.
Exactly. So the process of this guy becoming acetyl-CoA is called what?
Beta oxidation.
Exactly. And what's the point? Like when we actually get the fatty acids to acetyl-CoA, what do we do with this?
That goes into the citric acid cycle.
And then we can get more ATP. So it's like when you're fed, you have insulin, and then if you have, let's say, you're fat, and you know, in this case you'd be
hypothetically,
lucky.
Of course. Hypothetically, I wouldn't know, but
in this case, yeah, in this case you'd be lucky because you would have more fatty acids to break down before you start breaking down amino acids, which is basically breaking down muscles. And that would be very bad. Anyways, we're gonna look into the detail of this fatty acid to acetyl-CoA beta oxidation. I'm gonna draw that here. So like a mark here. It's not a long pathway, it's very simple actually. So start with the fatty acid. And it can be lots of carbons long. I'm just gonna put R. Just because I don't have time to draw all of them. So fatty acid. First thing that happens is what? Let me do this here. This is the alpha carbon, and this is the beta carbon. First thing that happens is what?
The beta gets oxidated.
The beta carbon gets oxidized. So basically, the first step of the beta carboxylation, first step of the beta oxidation is a beta oxidation. So you're gonna have the fatty acid like this. Then, so this is alpha and this is beta. This is where it's gonna be. Yep, I think that's right. Is that right? So it's alpha, beta. Yep. So this is the oxidized form. But think about this. If something's getting oxidized, something has to be reduced. And we know that what carrier oxidizes CH bonds to CC double bonds?
The FAD, right?
FAD. You know why? It's a very inappropriate joke, but
Okay.
I probably shouldn't say it. But it's this guy.
Pause the video, say it, and then restart it.
It's this guy. FAD gets reduced. FAD reduced to FADH2. First step of beta oxidation. Now the next step is nitration, right? Hydrate this guy. H2O. So now we're gonna have R. So this is almost like the citric acid cycle. I don't know if you remember from succinate to fumarate. Should I draw it out?
Yeah, might as well.
I'll draw it out real quick. So this gets hydrated, and that's the OH comes into the beta carbon. Alpha beta. Yeah. So that citric acid cycle, it's what's the structure? Succinate. Let's see.
You probably don't want to draw much more to the right, or else it might get harder to see. You can still see it just fine, but
Yeah,
don't
wait,
draw to the right
yeah,
anymore.
Can you look up succinyl-CoA? I don't remember low key what the end. Succinyl-CoA. Wait, right here. Succinate. Okay. So it's 1, 2, 3, 4. All right, that's good. All right, so it's 1, 2, 3, 4. All right, so this is succinate. 1, 2, 3, 4. All right, and then this goes into what? Succinate. Oh yeah. Oh my god, I'm sorry. So this gets oxidized. Remember, this is the guy that's in the electron transport chain as well. So succinate goes into fumarate, right? Here. The CH bond gets oxidized. And what happens here? FAD gets reduced. FADH2. Exactly the same thing. Succinate to fumarate. This is complex 2 in the citric acid cycle. And then this guy goes into malate. And that's dehydration, right? Water comes in and becomes this. Wait, shoot. Like that. And this is malate. And this guy gets oxidized, right? The water hydrates that. And this guy gets oxidized into oxaloacetate, which is this. Oxaloacetate. So it's basically the same thing happening here.
Very similar, yeah.
The oxidation of the CH bonds to the double bond, and then an hydration. And what comes next? You're never gonna guess it, right?
The dehydrogenase, right? Or you like?
No. Look, oxidation, hydration, and
You turn it into like the double bond, right?
exactly, oxidation again. So it's oxidation, hydration, oxidation, OHO. That's basically what's happening. And so next step is the oxidation. And the final step, this is where all we have to do is cleave this. Cleave this. When we cleave this, what are we gonna have? We're gonna have acetyl-CoA, right? This is basically acetyl-CoA.
Mm-hmm.
So we're gonna have the product is acetyl-CoA and what? Plus the rest of the fatty acid. We're gonna have this coming here, and that's gonna be goods. There. So we have the fatty acid. We broke it down to 1 unit of acetyl-CoA. And how many units of carbon do we have left? 1 and 2.
And then however many that R stands for.
I'm gonna call this. I'm just gonna leave this as a carbon, just so you get this point real quick. See, we started with 1, 2, 3, 4 carbons, right? 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5. And now, how many do we have left? 1, 2, 3. So think about that. In one single beta oxidation, how many carbons get lost? 2. 2 carbons get lost. Because 1, 2, 3.
Yeah. 2.
1, 2, 3, 4, 5.
Yep.
Where do those 2 carbons go? Acetyl-CoA. 1, 2. Literally. 1, 2, 3, 4, 5. And where does this guy go?
Goes to the citric acid cycle.
Acid cycle. And so it just keeps breaking down. And the next one would be breakdown of this guy.
Mm-hmm.
You know? It would be a lot longer than 5
So,
carbons, obviously.
so for that remaining, you only do it one more time because there's only one more beta carbon, right?
Well,
so you can't do it like more than one more time.
That's what I'm saying. That's why I put R before.
Mm-hmm.
It's going to be a lot longer than 5
Mm-hmm.
carbons. This is just an example.
Yeah.
So obviously in the body it gets to a point, right? Like
Mm-hmm.
when
You only break it
finish
down
the
so
fatty
much.
acids, that's when you go to amino acids.
Mm-hmm.
But it's going to be a lot longer than 4. It's like 24 at
Yeah.
least. Yeah. So that's beta oxidation. Simple. So just probably take a picture of this.
Do you want me to end the video?
Yeah. Please.